Hello, Tor. Hi, James.
Hi, greetings.
Mm-mm. So, Boone, sorry, Tor, can you hear me?
Yes, I can.
Okay, good. So, because today I'm traveling, not in the office, I didn't prepare much for the meeting. So I basically want to go through the attestation issue that you were bringing up. I only read and replied the first issue. The other one actually haven't read. So Tor bring up this issue that without including the public key in the attestation in the data object being signed, it's not possible to recover the public the public key of the attestation signer through the signature alone, right?
Yeah.
Yeah, and then there are two public keys that are often being talked in a message being signed. So one of them is if this message being signed is attestation to a key holder. For example, you are attesting that a key holder has the right to enter a FIFA game venue. Then you need to mention the subject public key. And the other is the case where the attestation was not supposed to be used like by a specific known person, but in a game where other participants can participate. For example, if you send ether to if you send ether to someone by email address, basically you are say the attestation data will say the data object will say that this data allows 1 ether to be redeemed if somebody can provide attestation of ownership of the certain email address. Therefore, there will be no subject public key in such data object. So the issue here is there any I had a rough impression that in XO 509 the public key was in there are two places for public key, the signer's public key and the person being attested his public key. But I couldn't find evidence of that, so I could have imagined the whole thing about the verification key being signed.
Yeah, as far as I know, it's only there through the certificate chain.
All right, so that is good to know. That also means that in encoding the attestation, we somehow has to encode a recovery key, in case the algorithm is DSA, of course. Sorry, we have to encode the v value, the selector, right? Tor, let me explain a little bit more. So the reason that we must encode v value instead of simply passing the smart attestation to the smart contract and let the smart contract figure out the v value, which can also be done. The reason we don't do this is because more often, very often, when we pass data to the smart contract, the smart contract identifies keys not through the public key, but through the hash, which is the address. You take the hash and take the first 20 bytes, that would be the address of Ethereum public key. And then Ethereum, other smart contract and other authors are very familiar with identifying signer through address. Therefore, if you don't, if you are not able to get the correct public key, then you cannot get the address. And because address is the identifier often being used, it makes sense to get to be able to derive address from from the attestation signature. Sorry, the attestation URL. URI actually. That's why we have to. I think that's why we need to make attestation URL in such a way that anyone can derive the address, signer address.
Yeah.
Yeah, and also in traditional X509, I guess, is there a clear distinction between validation and verification?
Between what do you say? Between
verification of a signature and validation.
I would imagine that validation also refers to like the format and the whole thing rather, but I'm not completely sure about the semantics in this case.
I myself tried to be disciplinary about using these two words differently. So verify means verified authenticity, and validation means validating if the asset is usable. So for example, if I get a FIFA ticket, and the signature shows that it's signed by the official ticket distributor, then I have verified the FIFA ticket. But the validation of the FIFA ticket depends on if the ticket has expired or if the event has been categorically cancelled by the smart contract. So let's say you get a verified signature saying that I'm ready to sell you the house. This is a signature from Weiwu, which says I'm going to sell my house to you for $1. And you're quite happy you can verify the signatures from me. But this one might fail validation, as it turns out that the house I'm selling to you actually doesn't belong to me.
Right, yeah.
So validation is not about signature. It's about the token. And verification is about the signature.
Right.
Oh,
so can we say that
if I have never
validation
explained
is
this
more
before,
about this?
if I've never explained this before, it would be great if you mentioned that in the document.
Yeah, okay, all right.
Boom, sorry.
Oh, sorry, I was asking, then can we just say that validation is more about business rules?
Validation is done by a smart contract, typically.
Right, but the thing that is being validated, it sounds like you can loosely describe them as business rules.
Yes, you can. You can, well, it's better to say smart contract because then we get certainty. So we know that if something that cannot be validated by smart contract, then business may fail to execute a certain rule, but we can still say the thing is valid.
Okay.
So the idea is if you make a smart contract that can work with attestation, you have a validation function that can give you true or false, depends on the attestation. And if you have to go to a business website to get a return value, if this thing is still valid, then it breaks availability. It also breaks an atomic transaction because now you cannot do a transaction because transaction has to wait for data from the web server, and you know blockchain transaction cannot wait for anyone.
Okay.
Yeah. Okay. So about the attestation URL and about attestation itself, I had this idea that the attestation should be verifiable without blockchain, but the validation depends on blockchain. And does it make sense? So you should be able to check the signature, and you should be able to check the signature. Maybe you should. Yeah, I think.
What about revocation?
You should be able to find out who signed this thing, but whether or not like the address of the person who signed the attestation, but whether or not he actually owns the asset. Like I sell you a house that I don't own, this kind of validation rule is elsewhere. And traditionally in X509, this validation is done by the upper level certificate, like CA certificate, right, Tor?
Yeah.
And traditional in X509, verification also depends on the CA, because you wouldn't know the address. You wouldn't know the public key.
Yeah, I mean, usually you have the issuer field of whatever X509 certificate you have, and then on top of that, you have a certificate for that issuer field that is signed by something else, all the way up to the root certificate, which is stored in the browser or locally on the system.
Yeah. So if you imagine, like, I sell you my house, then my land ownership as a signed attestation is like CA. Okay. So
yeah.
So that's it. Sorry, Boone, did I interrupt you again?
Sorry, no, I interrupted you. But my question was, what about if the signature is revoked, or can the attestation itself be revoked?
So revocation is similar. I think the revocation is similar to the situation that I sell you a house that I don't own. Like whether or not I sell you a house that I don't own, or I sell a house that previously I owned, but by the time you want to transact the house, it's no longer owned by me, therefore revoked. Or that the land office decided that actually it was another Zhang Weiwu, so he revoked my ownership of the house entirely. I think all these scenarios are treated the same.
That makes sense for revoking the attestation, but what about if I revoke the signature? Does that?
You mean that, for example,
not the signature, sorry, the private key.
You mean that you lost your private key and you want to make everybody know whatever you promised before no longer stands because the key is no longer yours, right?
Yes, perhaps it's a signature generated from a smart contract wallet.
Yeah, that's a very good question. In fact, I think in the future, attestations will not made by attestation will no longer be made on the subject public key. Instead, it's made on the subject virtual contract or subject contract, which is a contract that can be created if the user loses the key, or the contract has already been created so that the user can reclaim through the contract rule. So let's say there's a contract that says that with a lawyer's attestation, you can regain your identity, or that you can lock your contract, make it not possible to transact anything by having two friends sending a transaction to that contract. You can lock it for 30 days and you can get a lawyer to to attest your new key. Then this contract, instead of your subject public key, will be attested. So it's about the subject public key, not about the signing public key. So we're going to replace subject public key with a contract address in many use cases.
So like you say, if the contract is locked for 30 days, up to 30 days, we'll have to communicate with the blockchain in order to know this. Or are you saying that this is part of validation?
This is part of validation, it's not verification. Verification basically check that, yeah, this message is signed and the signer is this address. That's all. Whether or not this address still have the right to sign anything, in this case, it depends on the guardian contract, the wallet contract. You know which one I'm talking about, not depending on the land title office contract. But either way, it depends on the contract. So, Tor, I'm thinking that there are two ways to solve this. One is we have an additional verification key in the attestation URL. Sorry, not verification key. Selector in the key selector in the URL, which is very protocol dependent, or that we encode the verification key in the message to be signed. But that if you feel that is clumsy, then maybe it is.
I'm not sure what you mean by key selector. I mean,
the V value, Vitalik value. I will see Vitalik value in the future. Okay.
Yeah, but aren't we already I'm sorry, I think I'm misunderstanding something, because aren't we already missing that from like the signer of the attestation?
Pardon me?
Are you, so I mean, um, yeah, I think I got lost here a bit, because aren't we, I mean, the issue is we cannot verify the attestation because we don't have the key from the person who signed the attestation.
I see. So let me try this, okay? Um, uh, well, I'm not terribly good at terminology, but let me try this. So let's say we define verification as you know who is the signer by his address.
Yeah.
You can assert who is the signer by his address. Like you can see 0509 signed this attestation. So there are two ways to get 0509 as the Ethereum address. There are two ways to get it. One way is that the signature, the URL, the attestation URL contains a V value, Vitalik value.
But
and because,
where's because we talked about not including. Okay, I see. Okay, but no wait. Okay, I'm sorry. I'm still confused. Like, my understanding is that attestations as such are not necessarily directly on the blockchain, right? Or they are.
say the question again.
Are attestations always on the blockchain, or do they exist as a loose entity?
Attestation is a signed data object, and then it may be passed to the blockchain.
Okay, because I mean, no, I mean, okay. So if it's passed, if it's on the blockchain, then of course you can see the address, as you say. You can see the address of the person.
Not necessarily.
Okay.
I'll give you an example where I signed attestation, which I have assigned attestation to you, allow you to redeem 1 Ether from my wallet.
Yeah.
And then you will use this message.
Okay, yeah, I will post it on the blockchain. Yeah.
Yeah, which means the message comes from you, not from me.
Yeah, but then it means that that the public key needs to be of the signer, needs to be included. It needs to be somewhere, and not just not just the V value, like the whole thing, like, or a fingerprint at least, or something like that. Otherwise, it's not possible to verify the signature. I mean, from the signature we can restore the public key, but I mean that only makes sense if we can verify it against something, right? Because like any arbitrary value always has a restorable public key, but we don't know if it's a
yes. Yes. So you as the person who let's say I give Tor 1 Ether by signing attestation, and Tor has it, and Tor wants to redeem 1 Ether by putting that one on the blockchain and redeem it from my wallet, right? From Weiwu's wallet.
Yeah.
And he has to have the confidence that the wallet will not throw up and says that this message is not signed by Weiwu.
Yeah.
Right. So he has to be able to get the signer's address without calling the smart contract.
Yeah. I mean, so I can, like, from such an attestation, I can, construct an address based on the signature, and if I outside know it's from you, I guess I have your address somewhere and can verify that it was actually signed by you. But that's externally, which I feel is we're moving into a bit of a dangerous territory by having signed things that are not verifiable in themselves, like putting responsibility on something external to verify a standalone object, if it makes sense what I'm saying.
So you can I summarize it like you just signed message is like a certificate without CA certificate.
Yeah. Basically. What I would probably just do is my suggestion would just be to make issuer mandatory. So this would basically
Which
to
mean,
you.
when to the issuer, you mean the signer of the attestation, right?
Yes, exactly.
Yeah, okay.
And include, it doesn't even need to be the whole public key. It just needs to be the Ethereum address, because I can, from the signature, I can compute the two possible public keys, and I can hash them to get the Ethereum address corresponding, and I can verify whether one of them matches what is in the issuer information. And if it is,
yes, Tor, now I got what you mean. So can I
yeah,
say that back to you? So when you receive a message from me that I allow you to redeem 1 Ether from my account, before you do anything, even touching the attestation, you probably already know my Ethereum address. So you have
yeah,
this level of evidence, right?
yeah.
So that's, yeah. Should we build that into attestation, or should be in part of the protocol? Like the fact that I can send you something means that we have a connection.
Yeah, my gut feeling is that it should be part of the attestation. I see how like external situations will ensure that I generally know it, but we're trying to make something very modular that is going to work in a whole bunch of different contexts, and I will not be surprised if some developers find a way of misusing this, and we end up in situations where it's not possible to verify.
Yeah, and this issue information ideally should be signed by someone else, right? Or do you think
Yeah,
that
I
the
mean
issue
that's what happens in X509, that we have a like a certificate chain. But I mean, in Ethereum, it's not really like that. It's more like standalone. Then I can externally verify if this address is whatever I expect it
when
to
you
be.
say externally, do you mean that? So let's say now, let's simply suppose now that you can always get the signer's public key from attestation, and your question is whether or not this signer has any relevancy to what you are doing.
I can always get come again. Let me just pass this. I can always get the signer's attestation.
Let's assume that there's a technology that you can always get the signer's public key and Ethereum address from the attestation.
Yeah.
Let's ignore how it
Yeah,
is done.
yeah.
Let's say this is just
Yeah.
possible.
Yeah.
Then your question is, even if I can always get the signer's public key and Ethereum address from attestation, I do not know that if this thing is relevant to whatever I'm doing at the moment.
Yeah.
Right. So
yeah.
So to address that, we can produce a certificate chain, but it seems that it's more popular to do this on smart contract. So what you do here is you ask a smart contract to emit what is the address that is relevant to this transaction. What is the signer address that is relevant to the transaction you are conducting?
Yeah.
Or that you pass the entire attestation to the smart contract and get a binary result that whether or not this signer is relevant to what you are doing.
Yeah.
So that would be, yeah. So if you have, imagine you have a certificate chain and imagine that let's give it a name, Komodo, for example.
Yeah.
Then Komodo will be a smart contract. Then you will only receive the website certificates. And whether or not it's signed by Komodo is done by get current signing key from Komodo's smart contract, which will assume that they are managing well.
Yeah.
So that would be like more normal in the blockchain term, I think.
Okay, but I guess, I mean, you could imagine that someone just posts on an blockchain on a bulletin board some sort of attestation giving out an ether to the first one who does something. Mm-hmm. And before doing something and trying to yeah, I see what you're saying. I can always restore, I can always like construct two possible addresses from that, and I would be able to look that up on the blockchain in any case. I
have a question. Can I interrupt with a question?
Sure, please go ahead.
I just want to clarify with Weiwu. Are you saying that we include all of VRS? Because I believe Tor is saying that we are not.
There are two solutions. One is simply include the verification key in the message being signed, and the other is to provide a Vitalik value down to that level. If we don't, because basically Tor has upper level of discussion to the system, not to the method.
Okay, because it sounds like Tor is assuming that we can't derive the address.
But without Vitalik value, we cannot be sure.
Yes.
Yeah.
Yes, but are you assuming that we are going to make the change so that we can derive the address?
On that level, I'm not sure if we should add a Vitalik level or we should include the verification key in the message on the attestation format design.
I don't think, I think it's more of a question if we want the contract to be standalone, because whether we include the Vitalik value or not, I mean, it's basically, it's just, as far as I remember, it's just a sign of like the x-axis of the of the elliptic curve representing the public key, which, as far as I know, is going to be, I mean, it's not going to collide with any other public keys, except with, I don't know if it's impossible or if it's just very small probability, but I mean, it shouldn't happen. So like we discussed last week, you should be able to just brute force the two different attempts, construct two possible public keys.
Yes, but let's say you
post something to the blockchain or that includes
Tor.
Yeah.
Are we talking about why there needs to be certainty to get the signer address from attestation at all?
I'm unsure why there needs to be certainty down to the level of whether it's this specific one, if it's like if there are two options.
So Tor, your question is what is your question is, as a user agent, which is a piece of software that interprets attestation, URL or what, as a user agent, it might be satisfied knowing that the message is signed by one of the four keys, instead of being certain which key signed it.
Yeah.
Yeah. So my argument to that is you don't know the business context. So for one example, you might want to look up the balance of a certain account.
Yeah.
Then you have to look up four balances, and
isn't it just
pardon? Mostly just two, right? Yeah,
Yeah.
most two. So you have to look up two balances. Yeah. And the other is some smart contract author may choose not to return the address of the trusted signer. So imagine that a Komodo smart contract choose not to implement which is the key that you can use to sign website certificates. Imagine this. Instead, it asks you to give it a address, and it will tell you in the binary value that yes or no, that this key is allowed to sign web certificates. And the reason that website choose to do so might be implementation specific. For example, in a game where a lot of users could probably sign something, the smart contract might choose to include a filter. What do you call it? The filter that that is a hash of a lot of things. Bloom filter.
Yeah.
So for example, it uses a Bloom filter to test if a key is one of the participants of the game,
Yeah, yeah.
then it cannot return the list of keys that you have allowed. So it's there's always it makes the game, every game you want to design.
Yeah. I completely agree with that. I totally agree. That's also why I think like both because of that, and it makes a lot of sense. And that's also because of, as I mentioned earlier, like the usage of this attestation, because we don't know how these things are going to be used by developers, which is why I also believe that they should be verifiable. If not, I mean, they're not validable on their own, but they should be verifiable on their own. So I do think that that we should include the public, the address of the signing key.
Yeah, that can be the case. Yeah. So you think that is better than including Vitalik value, right?
Yeah.
Yeah,
because
I feel it's better
we're
too.
already having to add something extra, and now we have it stand on its own in itself, like the attestation.
Yeah. So I actually personally I like the feed. Personally I like not using Vitalik value because it look ugly. But
Yeah.
can we justify that on the logic base? Like why Vitalik value is evil?
I mean, by now we have more of a self-signed certificate thing if we include the address. So basically, this proves.
Maybe one of the
Again, it's
arguments
hard
is
to
that it
imagine,
works with other signing
cases.
algorithm.
It's hard to imagine all the use cases, but I mean, it proves basically that it shows what the address is in itself, without you actually having to do some computation, which is also easier. If you look at the attestation, you can see the address itself and look it up in other cases, and more instead if you want to cross-reference, and then just verify it afterwards. It also ensures that whoever made this has the private key. And I mean, if we just reconstruct the public key, I mean, you could have like included a fake signature or whatever. It just seems more robust and complete to me.
Well,
there are a few small advantages, as I mean, these few small advantages I mentioned of it, which might not ever have any specific relevance, but they could have that, like a couple of small advantages. Also, I think semantically, it makes more sense to have an address in the issuer field than a Vitalik value.
Yeah. Also, imagine that although in order to do a transaction, you have to use ECDSA, but in order to do attestation, maybe you can use RSA as well, or maybe even other signing algorithm.
Yeah.
So you can see that only in we can see that the verification key is always included. So you can at least verify that attestation before validating it.
Exactly. That's
otherwise it's DDoS attack to the smart contract.
Yeah.
Then you can if it's ECDSA, then when you make the URL for it, you can omit the address, but it's actually constructed in the memory.
Okay, I thought actually we wanted to only include ECDSA to start with, after a previous discussion we had about like the different.
Yeah, I use the ECDSA. Yes, at that time I used ECDSA, and I wasn't. I was wrong. I think attestation should be more flexible because the testers might use too many different systems. If a smart contract author decides
this also means that the URI becomes bigger, because now we have to include.
If the attestation is not in ECDSA, then URL will be a lot bigger.
Yeah.
Which we will say, like, that's why we suggest you to use the ECDSA. But on the specification level, we don't fix it. Maybe that's one way out.
Okay. Making some notes here. Okay. But I guess we still need like to specify when we're using ECDSA. So this still includes having to include the
Verification key in the message.
yeah, the signature, not or just the address, but also, I mean, we need to include the OID in the signature field, a signature algorithm field.
The OID of the signature algorithm, right?
Yeah. Like before, if we just assumed it was ECDSA, we could exclude it. So things was more.
Tor, I don't remember in very detail, but I do remember that, I think the attestation has this structure, that first inside the attestation, there is the signed message, to be signed section, and there's a signature. And in the to be signed section, there is that object plus a few other stuff. So I guess the address is in the other stuff section, right?
The address is in, hold on.
So I roughly remember it is two-layered structure. To be signed data has all that object in it, but to be signed data is not equal to that object. I could be wrong, because that gives us some flexibility to add metadata.
Okay, I see what you're saying. I thought we just signed whatever.
Yes, I do remember. Tor, you remember serial number?
Yeah.
Serial number is not in object class, but it's in to be signed data. Therefore, it is two-layered.
Yeah. Oh, okay. Now, gotcha. Now I understand what you mean. Gotcha. Right.
Yeah. So there are two layers. Therefore, you should be able to put the verification key or address outside of to be a data object, because it doesn't belong to that.
Yeah. So that's what I mean. But the issuer is still going to be outside that. Like if we base it on the X509 specification, I mean, issuer is going to be outside our
attestation signer.
Yeah.
Okay. So there's no reason to put it in, I guess.
Sorry?
So there's no reason to put, wait a moment. If we put it outside, then we cannot shorten the URL in ECDSA case. Because if you have ECDSA signed attestation and the signer address is at the place where serial number is, then you can verify the signature, and there's only one way to verify the signature. And then you will be able to know for sure which is the correct address. But if you put it outside, then unless you specifically mention that in the URL, making the URL quite long.
But I mean, so the URI is basically, I mean, it needs to be based on the DAR encoding of the attestation, which is based on the X509 certificate. But we're cutting out a few things which are not, which could then be deduced from the context. So yeah, it would be longer, but I mean, is that a problem? As far I read up on it, and basically like it should be like specification wise, URI and URL should be able to be unlimited in practice. Basically everything can handle something that's at least 2,000 characters.
Yeah, so you are making an argument that we can actually include address in a signer address in the attestation URL. Yeah, that's I was kind of hoping that we can not do this in very specific case like ECDSA, because if the URL is too long, the user will stop looking at what's in it.
What do you mean looking at? Do you actually
right now we made a bit of effort to make the core, made a bit of effort to make the data object visible to the naked eyes.
Okay.
And we made the signature after it. If you see something 2K long, then you probably wouldn't start. Even currently, it's already not very good because it's 3 lines long, and that object is in first line.
Yeah, okay.
Yeah, that's a small argument to be made, though, I know.
Okay. Okay, so you actually don't want, okay, so you don't want any base 64 encoding of the data object.
If we do encode it in encode address in the URL, then we should encode it in the Ethereum format, not base64, I guess.
What do you mean with the Ethereum format?
That is 0x followed by the hex representation of the address.
Okay. All right. Yeah.
If we do include the address though, I see what you mean here. That if we want to include the signer verification key into at the same place where serial number is, then we will break compatibility with X509. Is that right?
I mean, the serial number is basically an integer, but I mean,
I mean, not replacing it, but on the same level in terms of container sequence.
Yeah, I'm sorry. I think I'm misunderstanding misunderstanding the issue, because I mean, basically how we encode the attestation does not have to, of course, fit X509. I mean, that's customly passed. It's just whatever comes in and out is derived and look like X509.
Yeah, and it would be great to have to be compatible too. Yeah.
So, but I mean, like, I mean, the URI is of course not. It doesn't have anything. That's what I mean. The URI has nothing to do with X509. Only what we actually
designed it to be
encoding and decoding. So
yeah.
There's no problem including the address out there. I mean, basically the issue is a name object, which is, hold on, I have the RFC here.
I'm open to RFC as well.
Yeah, relative distinguished name, which is basically a set of attribute and value types of like the specific ones allowed in this case, like what's the name? That's yeah, that's like country or region, country, locality, organizational unit, common name.
Oh, that's interesting. So you look at TBS certificate, to be signed certificate section. There is a issuer. Can't we simply say that the issuer, instead of using a name, because we're not using issuer RDN as well anyway, can we simply issuer, instead of name, we put the Ethereum address there?
Yeah, so that's what I'm thinking, but that's basically breaking the compatibility. But there's nothing wrong with us, like basically just saying that instead of having using an issuer, instead of using, I mean, all of these are optional, like whichever we want to include. So instead of using common name, we just have the address there.
Yeah. Issuer name, is that name field a RDN?
Yeah.
Or is that name field a text?
It's an RDN.
Damn it, these people. I don't want to break RDN. Yeah. Yeah.
But I mean, isn't it right that there's no problem with us? Because I mean, as far as I remember, these are all like different kinds of strings, right? Text strings. So there's nothing wrong for us to basically just say by definition,
address equal to something. That's the RDN.
A common name is the yeah, the common name or the organizational unit is the Ethereum address or public key.
Yeah. So we simply say that the issuer name.
And then of course in the encoding and decoding, you know, we do this customly, so it's readable in the Ethereum format.
Mm-hmm. Yeah. So that should do it actually.
Yeah.
Yeah. That should give us short URL as well. And we have that in the TBS certificate. Yeah. That actually sounds like it might work. Yeah. Yeah. Okay. I think it can work.
Yeah.
So we're doing that way. I'm happy with that. That direction.
I'm happy with that. Yeah.
Okay, good. So yeah, let's fix the detail through emails. So this is for 45 minutes of discussion.
Also in regards to like as I'm working on this spec, I had like one question that confused me is that in our previous discussion, we when we encode this, we want to encode first the address of the contract, and then a question mark, and then the encoding of the attestation.
Well, that's one idea I had, but the other idea is you can also issue even the contract into the attestation, but that's limiting the make the attestation less portable, and Bourne didn't like it. So we put
my
that.
question is also, you mentioned that was mentioned in a previous specification of this that it can be that it should support multiple contracts, but is that just through distinct URIs that we consider this?
Yeah, so the most portable way is that anyone who construct a attestation URL is able to randomly combine a URL with a smart contract, so that any attestation can be used with any smart contract. Not sure if it's a good idea though, but we achieve the portability.
Okay, so it's just like for every contract, there's a different URI. Got it. Okay. That's,
and a hacker, an adversary, can randomly combine a attestation with a different contract, and it's up to the token script of that contract being trusted by the user to decide whether or not this attestation is usable. So let me speak that slowly. Any adversary is able to randomly change the association of attestation and a smart contract.
Yeah.
You can simply take the attestation
and
change the address, and then it's up to the token whether or not the token script for that new contract is trusted by the end user. It's up to whether or not this is true that decides if the token script can be used there. Yeah. So that's the current model. Maximum portability, not very tight security, I guess.
All right.
Yeah.
The final question is in regards to encoding of data objects and smart contracts. I guess, are we planning on having an ASN1 representation or specification for such formats?
Yeah, the idea is to have ASN.x, which is an XML translation of ASN.1 module.
Okay.
And that is embedded in the smart contract. So the idea is, without TokenScript, the client is not able to figure out what is the data object being attested. Although it can verify the signature, it cannot display any useful information in the format the users love to see without corresponding token script, which contains ASN.x.
Yeah. Okay.
Does that work for you?
Yeah. But basically this, as far as I can understand from this also means that we can assume that there is a deterministic DARE encoding of any kind of smart contract or data object.
So there is an, you mean there is a schema for every data object?
Yeah.
Yes, and they are signed by the contract issuer or the websites.
Yeah. All right. That's good.
Yeah. Okay. Thank you very much.
Because the issue with recursive data objects.
So it can happen if the user doesn't have the right token script or the system is hacked, that user cannot open the link because the data object doesn't make sense to the client.
All right. Yeah.
Okay. So far so good.
Yeah.
Thank you very much. If something is difficult to understand in my description, it's usually because I made a mistake.
Yeah, that's why I asked.
Okay, that's all right. Yeah, all good.
Thank you.
Yeah, okay, thank you.
Bye.
Bye.